Okay, page 2. Okay, so the first one, find the roots of each equation. Remember, roots is the same thing as x-intercepts or solution. Basically solve for x. Okay, so now I notice right now I've got two terms on this side. They both have x and it's already equal to 0, so I'm going to do GCF. Okay, so that's negative 3, so that's what I'm going to divide out. I'm going to divide out negative 3. But they also both have x, so divide out x. Okay, so negative 3 goes to the front. Okay, and then we're going to have x minus 3, okay, in order for that to be equivalent. Okay, so now the first solution will come from here. 3 times what number gives us 0? I'm sorry, yeah, just 0. And then the next one will come from inside the parentheses. What number minus 3 gives us 0? 3. Or x is a liar. If that's negative 3, that's positive 3. Okay, you could also do the quadratic formula if you'd like. The A would be 3, the B would be 9, and then since there's no C term, it's 0. Okay. All right, so now the next one. Okay, notice that I have just x squared on this side. So that if I have only x squared in the whole equation, I know I can do square roots. So first I'm going to move this 125 to that side. It's negative 125. So now it becomes positive. And again, to do square roots, I need to have this number be, this has to be 1, so I have to get rid of that 5. Divide it. X squared equals 25, and just square root. And then you guys can see right away that it's going to be plus and minus 5. Okay. Okay, so now this one. Okay, well now I notice that that has x cubed, x squared, and x. So they all have a common x term, and they all have a common factor for the coefficients and numbers as well. So I can divide, let's see, 4 into all of these. But I also notice that they all have x, and they all have at least one x, so I'll divide 4x. So 4x goes to the front. Okay, and don't stop there, you might be able to keep going. So this would be x squared, then minus 6x, then plus 9. And now what I notice is that x squared minus 6 plus 9, I can factor that as well. I can do the shortcut there, or I can just do a quick x. 9 goes on top, so negative 6 on the bottom. Be negative 3, negative 3. So x minus 3, x minus 3. All right, now I can find the solution. So first, starting with that, for x, since I have a number with x on the outside, that's going to give me a solution, because 4 times x is 0. I mean, 4 times 0 is 0. Okay, then these are both the same, both x minus 3, so that means there's only one more solution, which is x equals 3. Just like over here where it's x minus 3. So now we have 2 of them. Okay. All right, so now over here. All right, so you can approach this a couple of different ways. So let's see, if I bring the 24 back over to this side, let's see if we can factor it. Factoring is always the easiest one I like to start with first. Okay, so I'm going to try to the x. I'm going to put 24 up here, 10 here. And I try to think 6 and 4. 6 and 4. Okay, so 6 and 4. Okay, so that works because 6 plus 4 is 10, and 6 times 4 is 24. So x plus 6 and x plus 4. Remember, you have to move all the other terms to one side so that it's equal to 0. You've got to do that first before you solve any of these. Except completing the squares or square roots are the only ones you don't need to do that. Okay, you're actually moving that term to the other side. Okay, so then the first solution is going to be x minus 6 and x equals minus 4. Okay, because they're both plus, so x is the liar. Boom. Okay, so now over here. All right, so now this one. Now when I start seeing parentheses like this, I'm thinking let's use the square root method. So first, let's get rid of this 8, minus 8 both sides. But in order to do square root, I need to get these parentheses by themselves. So that would be 72. Then I got to get rid of that 3. So divide 3. So now x minus 5 squared. Okay, and that divided by 3 is 24. And now I want a square root. Okay, so x minus 5. Okay, equals, remember, plus or minus 24. Okay, then we're going to add 5 to both sides. So I'm going to move the 5 over here. X equals 5 plus or minus square root of 24. But remember, I asked you guys to do all decimal now. So first we're going to do 5 plus the square root of 24. And remember, round that to the nearest hundredth. So that will become 10. So we have to round up to the next one. So that'll be 9.90. So we'll have x equals 9.90. Okay, and then the next one is minus square root of 24. So just go back up here and change it. So we have 0.10. Okay. Now this last one. Okay, so I'm thinking, could I do the x? Can I factor? Okay, well, -1 times 4, that's -4. And then this term goes down here. Okay, the only way I'm thinking is maybe we can do a 4 and a 1. And this has to be negative, so one of these has to be negative, right? So let's do that. Okay, that works. Okay, so we can factor this, but remember, if that first term is bigger than 1, we also have to do the box method. Okay, so we're going to use the box method. We probably haven't done this in a little while, since the last chapter. Okay, so first, actually no, we didn't do this chapter. So the first term goes here. It's the pink notes, if you guys remember. So then -1. The two numbers you found go here, so -4x and then 1x. And now you've got to figure out what numbers go here on the outside. Now remember, the easiest way to do this is to find the GCF between columns or rows. So if I go in this column, the greatest common factor between 4 and -4 is 4. Okay, and they both share an x, so I have at least one x there. So that means this has to be x, and then it just kind of starts to fall into place. X times what number is 1x? 1. 4x times what number is -4x? -1. Okay, so there's our factors. 4x plus 1, x minus 1 equals 0. Okay, now, if you guys remember, I can either take this off to the side and solve it, because putting a -1 in here is not going to make that 0. So I would take that off to the side and say 4x plus 1 equals 0. Move the 1 to that side. So that's -1. Divide both sides by 4. X equals -1 over 4. Okay, but again, the shortcut is that if that's plus, the answer is minus. And that second term goes in the numerator. The first term goes in the denominator. And it'll always work that way. The next one is a little easier because it's just x by itself. So x minus 1, so x plus 1. Or x equals +1. Okay, and again, remember, that's in your notes. Look for the solving by factoring page. That's like the last example in there. Okay, so name 3 quadratic functions that have a range behavior of -infinity, and 3 quadratic functions that have a range of +infinity. So what we're looking for is 3 quadratic functions that have a range behavior of -infinity. So really, all we're looking for is 3 functions that go down, and then 3 functions that go up. Okay, so let's start with, we'll do f of x. One simple one that goes down would be negative x squared. Then g of x, let's do -2x squared. Then I'll do h of x, make sure they're all different. We'll just say, again, -3x squared. Okay, now 3 that have a range range behavior of positive. Okay, well, that's pretty much just the opposite. Excuse me. So we'll do I of x equals x squared, j of x, and we'll change this one up a little bit. We'll say we'll do a vertex form version. Okay, so we'll do a positive number in front and put x minus 1 kind of randomly, plus 3 randomly. That doesn't really factor in. What's important is that number in the front, because that's going to give us a range behavior of +infinity. Okay, and then the last one we'll do k of x. And let's say, I don't know, we'll do 2x squared plus 4x. We'll do one that's kind of in a standard forming look here, plus 3. And again, what matters is that first number in the front is positive, positive, positive. And if its range of behavior is -infinity, it's negative, negative, negative. Okay? All right, so now the next one. Okay, so we have this standard form equation. We got to describe the different important pieces of it. So first, it opens which way? Well, it opens up, because the first number is positive. Axis of symmetry. Well, in order to find that, we've got to take this middle term and find the axis of symmetry by using you can use the formula, -b over 2a. Okay, so we'll have negative 6 times, or negative times negative 6 over 2 times a, which is 3. Okay, so then I want 6 over 6, and that's just 1. Now remember, axis of symmetry, we need to start with x equals 1. Okay, we always start with x. Then the vertex, okay, the vertex is going to be 1 for the x value, but then we got to find the y value. I'm going to plug that in. So then 3 times 1 minus 6 plus 6. Okay, so then 1 squared is 1 times 3 is 3, and then we'll have times minus 6 plus 6. Well, those 6's just cancel out, so it's just going to be 3. Okay, so now we also want to know about the min and the max. Okay, again, this is a graph that goes up, so that means we'll have a min, and remember the y value tells us the min at this point, and the y value is 3. So we'll say a min, and we'll say min equals 3. Okay, and then the x-intercepts. Okay, so first we're going to have to solve it. Okay, you're going to figure out what method you want to use to solve this equation. Well, right away I noticed that I can divide all of these by 3. So first thing is set it equal to 0. Sorry, all these terms. Set it equal to 0, divide it all by 3. Okay, so then I'll keep the 3. Actually, no, I'm not going to do that. We're just going to divide the 3 out, so 3 is gone. So we have x squared minus 2x plus 2 equals 0. Alright, so let's see if this works. So if I have 2 here, negative 2, well, only 1 and 2 works here. So that's not going to give us an answer, because 1 and 2 we can't really make negative 2 with. So we're going to have to use a different method. Okay, so what we could do is complete the square. So let's try that. So let's move this 2 to the other side. So minus 2, and then this will be plus 1, like we did before earlier in this worksheet. Okay, so then factor this. It becomes x minus 1, negative 2 plus 1. Okay, that's going to be negative 1. Now what you guys should be noticing right away is I've already gotten an imaginary number because I've got negative. So the question is there an x-intercept? No, there isn't. Okay, and we could actually notice that from the beginning. If we look at the vertex, it's at positive 1 and 3. So remember, the last part of this is we're going to have to graph it. So let's go ahead and put that on the graph. So there's 1 and 3, and it goes up. Okay, well, it never touches the x-axis, so that means we're going to have imaginary roots. Okay, so what I'm going to do is on the test, I'm going to change this to roots. Okay, so if I had asked for x-intercepts, you'd say, oh, no, there are none. But there are roots. Okay, so we're going to finish this out. So now we'll have x minus 1 equals, remember that's the square root of negative 1 is I. Okay, so there'll be plus or minus I. Okay, then I'm going to move this 1 to the other side. X equals 1 plus or minus I. And remember I said if it's an imaginary number, just leave it like that. You don't have to put in decimal form, and we don't need to because there's no square roots or anything like that. So here the roots are going to be 1 plus I and 1 minus I. So we'll just leave it like that. Okay, so now y-intercept. Okay, well then the nice thing about the standard form is the y-intercept is the last term. Okay, domain, well, all parabolas, let's just do interval notation. All parabolas, domain is going to be infinity both ways, left and right. Okay, now the range, now remember the range is determined by whatever that vertex is. That's the lowest point, which is 3. Okay, so the lowest point is 3, and then it goes up forever from there, so positive infinity. Bracket here, parenthesis there. Now, again, increasing and decreasing intervals. So increase. So starting from the left, it's decreasing. Okay, so it's going down. Okay, from negative, remember intervals is just the x. So from the left, from negative infinity, it's decreasing. Remember, the negative infinity is applying to the x. So as we come from negative infinity on the x-axis, it's going down. And then that decrease stops right here at the x value of 1. Okay, so parenthesis, bracket, and then the decrease, I'm sorry, I just wrote the increase, my bad guys. That's supposed to be decrease there, and then increase here. Okay, so then the increase starts here at 3, sorry, not at 3, at 1, the x value of 1, and then as x increases, or x becomes more positive, okay, then it starts to increase. So it's going to look like that. Okay, so now the M behavior. So remember, as this, we write this first, which basically means as x approaches negative infinity, as it goes to the left, where is the graph going? It's going up. So as x approaches negative infinity, f of x approaches positive infinity. So if our graph goes up, again, this will always be the same. You always write this, and then if it's going up, you're going to put positive infinity pretty much for both. Okay, and then the other way, as x approaches positive infinity to the right, f of x is doing the same thing, going to positive infinity. And if it was going down, then both of these would be negative infinity. Okay, the last piece is we want to graph it. Okay, so what I know the vertex, but I also know the y-intercept. Okay, so let's graph that. 4, 5, 6. So there's a important key point. Okay, so I know that y-intercept's 1 to the left, and it's up 3, so that I can just go to the 1 to the right and go up 3 again. And that's good enough for my graph. Okay, I want you guys to get at least 3 points to make it a nice, perfect, or not perfect, but somewhat accurate graph. So remember, if you guys watched the Edpuzzle video I had you guys watch, you also would know that if that's a 3, that next number to the left goes up 3. So that makes it easy to know. Or if that number was, let's say, a 2, then it would be to the left 1 and up 2. Or if it was a 4, it would be to the left 1, up 4. You're basically doubling. Okay? So check out that video if you didn't see it. Alright, and again, that was the not the x-intercept, but the roots of this equation, and not the intercepts. Okay, identify the number of solutions for the following quadratic. Okay, well, let's go ahead and find the vertex, see where that's at, and then we can go from there. Okay, so first we have negative 7. I'm going to put that, sorry, not negative 7. We're going to use the negative b over 2a. Okay, we're going to use this to find the vertex. That's what I mean. Okay, so we have negative 7 over 2 times 5. Okay, that's going to be negative 7 over 10. Okay, so that's the x value. Okay, but what's most important is we got to find what's the y value. Okay, so we're going to have 5 times. And what's important here is knowing where does this actually lie on the graph. Okay, so even if I don't get this exact value, I just need to know that that's either plus or minus. Okay, because I already know this graph goes up. I just need to know, is it above the x-axis or below? Okay, so 7 times 7 over 10 plus 1. Okay, so this is going to be 49 over 100. Okay, and then 49 over 10 plus 1. Okay, well, I'm going to stop right there. What I notice right now is that there's no negatives in this as I'm looking for that y value. So I already know that this is going to be plus. I'm not going to keep going because I'm not messing with those fractions. If you want, you could just plug that in a calculator, find the decimal, because that's really what you want to know. Is this going to be above or below the x-axis? So now we've got a graph. It's above the x-axis, right? So if it's above, that means there's no x-intercept. So there's no real solution. There's not one real solution. There's not two real solutions. And there's not one real and a complex solution. There's just two complex solutions. And there's really no case where you'd have one real and one complex anyways. So we'd have two complex, or two basically imaginary roots is what that means. Okay, that was